More than 5 supply chain attacks targeting big tech in the past 72 hours alone and counting. This has been an absolutely crazy week. And joining me today is Oleksandr Yaremchuk, CTO and co-founder of Manifold Security and creator of LLM Guard, which was one of the first major AI security frameworks. So let's dive right in to see where this madness is heading. What will the next iteration of supply chain attacks look like? Olex, thanks for joining this episode of Security Report today. And I just want to jump right into this with something that happened this week. More than 5 supply chain attacks in the past 48 hours alone. And because I think it's going to reframe everything we discussed today. So this used to be a big problem in the NPM PyPy world, right? But now we are seeing that every layer of pipeline hits simultaneously, and this has not slowed down. I feel like we keep seeing this. We saw this pattern years ago, and now it's just exacerbated with GitHub's own internal repositories hit up to 3,800. So the report says over here. So I want to discuss that with you. And I don't want to just talk about the attacks, but just where do you see this all going?
Yeah, awesome. Excited to be here and talking about this topic. I've seen it's kind of funny because we always seen like dependencies being a concern for like when you're building applications and like when you deploy them. So mostly like the attack is like on your infrastructure, which is probably like throughout years we managed to isolate it in some ways. You know, you have sandboxes, you have containers, you have like some airbag policies and so on. But the thing is, like, since like we've seen it in also like 2 years ago when like people started pulling models from Hugging Face, we saw the same thing, that there was like you could do like malicious Python code like just embedded in the model, and when you like pull it and run it locally for training, like you would have some vulnerabilities. But we didn't see like much of them. Like it was probably like 1 or 2 attacks that were like wide, and now with like agents and all these like MCP server skills that use like PyPy, use Python dependencies, use NPM dependencies, you will have them on your local, and your local has more exposure than like anything else. Like you have exposure to like infrastructure, Slack, Gmail. So the impact is like so different than it was before with just, deploying it like to some application in Kubernetes.
Yeah, this is what I was also seeing. I started off speaking about the legitimate libraries getting hijacked left and right. But even in terms of, say, like typo-squats, which are a package on NPM, it's pretending to be a legitimate package. We saw in some research reported on this. The thing I find interesting about the typo-squat is it's touching your Claude settings. So it's already like the attacker's frame has shifted. They're not even waiting for the next iteration of AI products. They're already assuming that on a developer's machine, Claude Code is installed. So they're already peeking into its config file and settings file.
Yeah, 100%. And I think like another thing is like typo-squats were like more of an issue. Like like usually people would have like some checks before that, but with LLMs, because you kind of rely on LLM to pick like the dependencies for you, the issue is like even bigger, because LLMs can just hallucinate and like assume that it's like for example, there was a common thing that if I'm not mistaken, the Llama model had like an organization. It was called not Facebook, or it was like Meta Llama or something. And it was not even Meta or Facebook AI. It was like Meta Llama. So people were like confused, like, is it the main organization or not? And the model as well is confused. So like it would suggest you like Facebook AI, and somebody can create an organization called Facebook AI. And so now, like, obviously, like it's much easier to just poison your agent, assuming that you have one for sure. Claude settings, cursor settings, like you definitely can just target like 80% of the market by, just assuming that somebody has like Claude code on their machine.
See, as a practitioner in the supply chain space, right, for nearly a decade now, and this used to be fun, now it's getting a bit overwhelming, I won't lie. Because where do you even focus as a developer? So just now I'm seeing this tweet on Megalodon campaign going on, 5,718 commits, 5,500 plus repos in a 6-hour window. And all of this is being done with Forge CI bot identities. So I think there's like the CI/CD pipeline angle, right? Which is where like say GitHub workflows, YAML actions. Then there's the traditional supply chain stack, dependencies and scanning dependency trees, which is what like SaaS tools do, SCA and SaaS. And now with like agent in the mix, I'm just like trying to connect the dots here. From a defensive standpoint, how do I even architect the defenses, right? If the attack surface just seems to be growing every day.
Yeah, I mean, exactly. Like it needs to be like defense in depth. And one thing cannot cover. So like one solution will not solve it. You cannot just put like, I don't know, guardrails or like just, I don't know, get some scanning of your code. It needs to be a lot of things at the same time. So whenever like, first of all, whenever you're choosing something outside of your environment, you need to always like ensure that this is safe. Now we are learning that actually you shouldn't even use the latest version, and you should kind of wait. Like a lot of like this new rules that like, okay, wait 7 days before like rolling out some new version. Like how you manage like everything external, that's like changing. The second thing that is changing, I think, like sandboxes are becoming like more widely adopted. It was a thing for applications in Kubernetes. Like you had containers and you used micro VMs and so on, but like never think for like desktop, like a laptop and, you know, like your endpoint. So it's becoming like a kind of second layer. Okay, if, you know, running everything in like a small sandbox that only has access to things that I allowed it to access. But the third thing, which like, okay, you need to assume that even if you put this and that layer, like you still probably will have attack at some point because like, you know, with Mythos, with other like models, people can do some really advanced attacks in your environment. So the third layer is obviously you need to constantly monitor what's happening, like in runtime, and ensure like, okay, this is agent just hallucinating, doing something like dumb, or this is like real attack that is happening because something is poisoned. Like something actually went through like all your like previous gates.
Right. And I think this also kind of goes into the MCP server Kubernetes CVE we just found, which kind of touches on this, that how the tool calls at statically, everything looks fine. But then at runtime, something else is happening, which the developer earlier hadn't accounted for, right? And that became a vulnerability. So yeah, if we're discussing like runtime, I think we've seen this pattern enough times with npm pypy, and now we have registries for MCP servers like Smithery. For skills, we have Vercel skills.sh claw hub registry. So I'm just trying to think, like, do you see this pattern kind of cascading into skills and MCP server registries as well?
Yeah, 100%. And I mean, the thing is like right now, it's hard to differentiate like for people, first of all, like it's very confusing. It's part of the marketing from like Anthropic, but it creates a big confusion. What is plugin? What is MCP server? What is skill? In the first place, because plugin is just like a bundle of skills, or it's a bundle of servers, and nobody really understands. So first of all, figuring out like what is what to start with, and the secondly, like the registries, they're helpful for people just like picking up stuff, like finding maybe something relevant that has the most downloads, but you don't really have like any clue there. Like there's no kind of nothing that helps you to choose the like right secure server that is well tested. Even actually, they're not providing you enough information like what is useful, like even as a skill or MCP server, like how it works, how it performs. So you just assume, okay, that it has like the highest downloads, most stars, like typical
Yeah.
open source stuff. So I think that's the issue with those when like you're pulling them, but also like the whole confusion, like how you should treat each of them, what kind of security you need to have in mind, and also like since it's early, specifications are not still like defined. The adoption is behind. Like you have, for example, like when MCP authentication spec was defined, the MCP servers, the most popular MCP servers, were behind by like 8 months of like following it. And still to this day, we have MCP servers that just use static API keys because like it's just easier, and like nobody adopted the actual proposal like specification that you need to use OAuth. So that I think that's the issue. Like it's not anymore just evaluating that, okay, it's popular, that's why I need to use it. But you need to also like look at the code, implementation, does it follow the spec, does configuration work? So which is like really complicated.
So just to what you said about MCP servers still not having a solid spec, right? That's why these vulnerabilities occur and are discovered by researchers. I think the other day I was discussing with a colleague, for example, with NPM, PyPy, and similar attacks, Ruby gems. We have a large corpus. We have seen what malicious looks like hundreds or thousands of times. We know what the iteration of it could look like. I think in this territory, to go back to your point about lack of a completely defined spec, there's a lot of unknown unknowns. So I'm aware some registries even integrate static scanners with them and try to assign the assets a scoring. Is this risky? Is this clean? And sometimes they give a warning that this may go either way. How do you, I guess, how do you prepare for something which you know so little about?
That's a good question. Like it's very hard. And I mean, we have certain like code scanning, but like it will probably catch you like some obvious things, or like you might tune it to the point that it's like very noisy and like not really helpful. And I think this is kind of like the balance we see in the industry. You have those scanners that are like, catching like very obvious stuff and maybe like useful enough, or the ones that are like going super detailed but like super noisy, like basically flagging like 46% of assets, like 46% of like skills on the internet. And then it's like completely not helpful because like you you might end up choosing like some like noise, and you end up choosing like a worse skill, but like there was a better one, but there was like some things flagged. Like again, I think like there is no silver bullet. Like it's not gonna be solved like by just scanning like the skill MD, for example, or just scanning the package. Like you need to have like a holistic approach. First of all, I mean, lessons from like supply chain security. Looking at like what are these things that you would look at when you are choosing some open source library. You would choose at the author, like when they started, this project. How like is mature is like this repository, like this and that. So like that's the first thing you need to look at, because it can tell you a lot. Like we see actually from these attacks, they all have, there is some behavior that is sort of like just before the attack. There is some behavior like a switch of the author, takeover, some other thing. So you could maybe like even catch some of those there. Then you need to have like proper scanning, and the scanning itself is also complicated because you need to combine static stuff like obvious attacks with AI. And finally, which is like probably the hardest part here, is like, is there a path for like runtime scanning, like kind of putting stuff in like kind of how we did like with malware analysis these days. Like they put it like in the sandbox, they run it, they look at like all the stuff that is out and checking like what actually did and like was it malicious or not. Many companies are doing this, so it's complicated. It's probably very expensive, and that's why like a lot of people just go for the most obvious, the easiest approach of like static scanning, without trying to like stack the multiple things, or at least like even start with like, let's say, uh, provenance, like GitHub,
Yeah.
open source checks.
Yeah. Yeah. No, good answer. Let's talk about lethal trifecta. And for the viewers who don't know what that means, it's when your AI agent is trying to do three things simultaneously: accessing your private data, processing untrusted input, and talking to the outside world. In 2025, Simon Willison, who also coined the term prompt injection before that, he was the one who came up with this term as a potential risk signal that something's going wrong if your AI agent is doing all three things at once. But I think lately the status of lethal trifecta has become a bit more than a risk signal, because virtually every AI agent is doing that at runtime. I think, Olex, you can explain this better than me, considering you see this a lot. So go on.
Yeah, I mean, like on one side, there's Simon with his blog and coining the term, and there is also on the other side there was like a rule of two from Meta. Like basically, it's the same but rewarded. That if you have three different things, like like you need to kind of like you need to have only two. Like you cannot have three at once, because then like if they combine, this is like malicious. The issue is that in most organizations, if you want to make your Claude Code instance useful, you will have lethal trifecta by design. And you can limit it. Like there are ways that, okay, like we are not, we will limit that. Like you cannot just go on the internet and look for stuff. You need only like to go to like internal knowledge bases and so on. But then I think that many teams realize over time that it kind of makes the agent like completely useless, or like, less performant than they actually expected. It's the same sandboxes and the same like with other stuff like that. You have like a trade-off. You either want agent to be like autonomous, create like be performant, and you can like have multiple simultaneous sessions doing like some development, or you create like those, like you kind of try to ensure that little trifecta is covered, but then the agent is like harder to work with. So our like kind of how we see it is that like in our system, we see it like in every environment, it's constantly flagging for little trifecta because everyone is using like Google search. Everyone that then like looks for some documentation of like some library that is, they pulled some library, they're using like documentation of that library that is also like a trusted source of information. And so like it's kind of like we see it across the board, like that they're accessing like private data because they, for debugging purposes. And private data is not like they're accessing the databases, like they're accessing logs even. And logs can contain private data because there are some like proprietary information, and you might not see it as obvious private data. So that's the thing, like kind of which is a debate we are having internally. Like, is little trifecta is a thing that we should prevent at all, or we should accept it and like kind of build certain defense around it, because otherwise like people will not have the agents will not be useful. And I mean there are organizations that will be kind of, they will need this, like highly regulated environments, but at the same time most organizations might not need it.
Right. Thanks for that thorough answer. Because I think this makes me think of fine-tuning signal to noise ratio, right? If just for example, the GitHub internal repo leak of 3,800 repos, and allegedly by the same threat actor TeamPCP that's been going relentlessly after open source projects. I believe this happened because an employee installed a VS Code extension. And I mean, what I'm trying to say here is, how do you fine-tune that signal to noise ratio? Because it's very easy to see several such signals, lethal trifecta being one of them, but an employee installed a skill. At a first glance, it looks malicious, and maybe it's burning too many tokens. You read it and you contextualize it. It's actually not a malicious thing. It's doing its intended job. And it's very common for people, developers to download stuff from the internet and just, even if it's a Claude skill MCP server. So that's what really I think the challenge is, fine-tuning your signals and getting rid of the ones that are useless.
Yeah, 100%. And I mean, we've seen it as well with like detection response. When like usually anybody that deploys detection response to their organization, they have the first few months of like just tuning for noise. I think there is another learning from there that usually engineers have like more exceptions and like more like kind of more relaxed rules. So I think the first thing when we're talking about tuning, the first thing we need to differentiate like patterns into like, we need to put them into buckets. One bucket is engineers and another is like non-engineers, because we are seeing adoption there as well, like marketing team, sales, go to market and so on. They're like using Claude Cowork, OpenClaw, like whatever, like those tools. So we need to first like put them in the different buckets, because engineers historically have had like a lot of like much less, much fewer rules for like to relax it a bit, because they access like a lot of like private stuff. It's needed. So I think this is where we start. And from there, like we need to monitor the patterns in that environment, because in some environments, like we might assume it's a private data, but like they're accessing this data, like for example, like it's like some random website, but then realize this random website is documentation of their vendor, and they're like constantly using that documentation. So it's like about like learning and tuning. But I would probably say that it's probably a trade-off you need to accept at the beginning, same as like people did with like detection and response, that it's going to be noisy at the beginning and like improved over time. Because it's better to get the signal, review it, and make sure, okay, like this is fine. Exceptions can be handled, can be like created. Then like just missing the signal because it will drive noise. And there's another belief in the industry, I think. These days, there are a lot of like this AI SOC, AI MDR companies that are trying to solve this exact problem. They're trying to like, okay, you have noise from like different sources, and then it goes to like a single place, and then you try to correlate and have like a sort of meta prompt that will decide if it's actually false positives or not.
Right. So just to what you said, there are so many solutions coming up in the space due to different challenges and attack vectors, right? There's gateways, there's obviously EDRs, there's static scanners. What specifically got you interested, Olex, in AI runtime security?
We started it like early, 3 years ago, when it was just ChatGPT, and I was like, the first thing that we started looking at, it was like the previous like generation of AI security, which was all about machine learning, adversarial image, like when you put like a sticker on, a sign, and then Tesla goes off the road. But we didn't see really like this as a risk, because everything was like very, like those models were like small, internal, and not like, we didn't really see like big attacks there. So when we saw ChatGPT, we were like, oh wow, that's something that can actually change the industry, because then like it's like the attacks can be real. But I think in the last 3 years of like seeing like kind of these chatbots that companies are deploying, we realized the risk is actually not security, because they're not really connected to anything except for like some knowledge bases that are like, quite isolated. The risk was safety, like brand damage. The model is saying something bad about the company, which was great, like to also have like some solutions, and like we tried to like solve prompt injections as well, but we just didn't see this like highly adopted. Like there was no massive usage on like copilots that
Right.
companies created. And so like when we saw Claude Code adoption, the massive adoption of other AI coding agents, it just changed the game. Like finally, we see, first of all, return for investment of like AI. The promise that everybody were making like 3 years ago is finally happening. That there's like efficiency and this and that. So it's great. And this second thing, like these things can actually act on your behalf. They have a lot of access, because it's like natural. You have a lot of access as
Right.
employees. So it's like things that augments you. And yeah, like we finally see that like there's a way to like actually be useful and create the actual security for those tools, and not just like, for example, some safety scanners that like prevent brand damage, but like something that actually will prevent the next big attack. And we also see the attacks on one side. Like we see unintentional, like insider threat, like when your agent is like just wiping your database, removing your infrastructure because he just decided that's the best way to achieve the task. But on the other side, like there's so much malicious stuff like on the internet, like skills MCP servers. So when you download them, like you have access to all your infrastructure, and this is what will drive like like this will what will help bad guys to attack it much easier. So I think that's like what really makes us like motivated to work even more on solving this. It's just that like there is real impact we're finally seeing.
So I guess for the viewers, what would one piece of takeaway be? Because things are changing so fast in this landscape, right? You see one kind of attack and vulnerability, and next month you're seeing mergers and acquisitions, two solutions combining into one. So what is your one piece of takeaway here?
Let's say like from the last 3 years that we've spent in in the space, I would say like the most important thing is like trying to um, like separate marketing from reality, um, because there's like a lot of companies will try to sell you like the silver bullet solutions, and like, okay, if you just deploy AI guardrails, like all your problems are gone. Like there is no prompt injection, there's no like malicious skills will be gone, everything will be gone, everything will be fine now. So I think we just need to accept that there's the only solution is defensive dApps, There will be no like silver bullet. There will be no like one thing that rules it all. And you need to build like, you need to use like whatever you had before, whatever you procured already in your organization for supply chain, for like, SIEM, detection response, combined with like the newer generation of tools that are like for AI agents. And then you need to use some other stuff that, you have like in your infrastructure, like, I don't know, for example, some gateways for centralization and cost management and so on. So like, I would say that's probably the main piece of advice. Like just, ensuring that like people are not catching just another shiny solution that tries to solve all their problems.
Yeah, that's really insightful. So I think for our viewers, I would ask you to leave your comments below what you think is the next attack surface worth watching for, and what are you doing about it. Olex, thank you for joining today's episode.
Thank you for inviting me.